We've already seen in other videos, nonmetals can join together by covalent bonds, in which they share electrons, so that all of the atoms have full outer shells. Sometimes this results in small molecules, such as hydrogen fluoride, and we call these simple molecular substance. Structure formula of hydrogen fluoride. So if we consider a simple molecular substance like oxygen, the atoms within each molecule will be strongly bonded together. However, in order to melt or boil oxygen, we actually don't break these strong covalent bonds. Instead, we only need to break the weak forces that exist between different molecules, which we call intermolecular forces. Because of this, we only need very low temperatures to melt or boil simple molecular substances. For example, oxygen boils at -183 degrees Celsius. Although these intermolecular forces are individually quite weak, when a substance melts or boils, now there is one further point: as we increase the size of the covalent molecule, the intermolecular forces increase. For example, let's compare the halogens, fluorine, chlorine, bromine and iodine. Because we're going down the group, the atoms and thus molecules are getting bigger. So there'll be more intermolecular forces between them. This in turn means that more energy will be required to break them all, so the melting and boiling points should increase as you go down the group, which they do. As fluorine has a boiling point of -188 degrees Celsius, and iodine doesn't boil until 184 degrees Celsius, you just need to understand that the boiling point increases as you go down the group, because the molecules get larger, so there are more intermolecular forces between them. Physical properties of simple molecular substances are summarized in the table. Most of substances are insoluble, but soluble in non-aqueous solvents, for example heptane or ether. Such as, iodine turns purple when dissolved in heptane. Another property to note is that simple molecular substances don't conduct electricity, because there are no free electrons, and the molecules themselves have no electric charge. But a few simple molecular substances react with water to form a solution which conduct electricity, for example hydrochloric acid. In an aqueous solution, hydrochloric acids dissociate to produce H+ ions, and chloride- ions. These mobile ions are responsible for the conduction of electricity.